Okay, for problem 1, we have this bracket and it's got two forces, and we're supposed to graphically determine the resultant of the two forces. I've drawn a line here to reference this line where I think the numbers will fit, and a point where I'm going to do the sum about. The Q goes down at 35 degrees. So I'm going to draw a line at 35 degrees. I measured the one over there and it wasn't quite 35 degrees. So there's 35 degrees. So that's the direction of the Q vector. And we go to 60 degrees to get the direction. Of the P vector. And now we need to find a magnitude. I'm going to choose 1 centimeter equals 100 pounds. So at 920, which was the numbers I had for this case, the magnitude is there, and at 620, which again are the numbers I had, you may have had different numbers. So we have our vectors. And we will use our triangles to draw parallel lines, to draw our parallelogram. And where they cross is the sum. A resultant of these two vectors. And it has a length about 10.54. So that's 154 pounds magnitude. And we measure the angle. At 23.5 degrees. That's it for that one. Second problem is very much like the first one. We want to sum the vectors graphically. So we have the P vector, which is going up at 25 degrees. So I'll mark that at 25 degrees. Draw the line. And the Q vector is going down at 50 degrees. So just mark it at 50. Make sure it's the right direction on the protractor. Now for my units, I have a 1/10 inch scale, or inches in tenths. So I can do a 1/10 inch to a kilonewton. So there's 17 kilonewtons. And here's 22 kilonewtons. Perform our triangle magic here to draw parallel lines. Looking where I'm going to end up after I slide. And we measure the magnitude. Pretty close to 31 kilonewtons. I would say it's just a little bit more. And the angle is minus, or is it 17 degrees? It's unclear from the description what angle they really want, so I will say down. That's all, folks.